Welcome to AI Pulse Daily, where the rhythm of intelligence meets the pulse of innovation. Today, we journey through time itself, from the crumbled pillars of forgotten temples to the hidden codes of neural networks. We explore how artificial intelligence is helping humanity rebuild what time has erased. This is Rebuilding Lost Wonders with AI, Ancient Archaeology's New Frontier. Imagine walking through the dust of ancient civilizations, Egypt, Mesopotamia, Greece, the Indus Valley, where every grain of sand hides a story. For centuries, archaeologists have relied on fragments, scrolls, and their own imagination to piece together history's puzzles. But now, a new archaeologist has joined the team, one made of silicon, code, and computational vision. Artificial intelligence is breathing new life into ruins, reconstructing temples, cities, and even entire landscapes that human eyes thought lost forever. As we open this episode, the sun rises over a digital Alexandria, through Great Lighthouse, once guiding sailors through the Mediterranean. Now stands again in virtual form, reconstructed through AI analysis of seabed scans, old maps, and historical texts. It's more than just a simulation. AI has transformed fragments into form, whispers of history into voices of stone, in laboratories from Oxford to MIT, and in research centers across Europe and Asia. Scientists are using deep learning to decode archaeology's riddles. Algorithms, trained on terabytes of data, aerial imagery, satellite scans, and LiDAR data, can identify hidden sites buried beneath soil or sea. For example, in 2024, a team at the University of Cambridge used an AI model to detect subsurface patterns in the deserts of Sudan, revealing an entire network of pyramids previously invisible to the human eye. AI isn't just finding what's lost, it's imagining what once was. Through generative design, neural networks can reconstruct missing details of architecture, artwork, and inscriptions. In Italy, the Pompeii Reborn project uses GAN's generative adversarial networks to fill in the missing frescoes of Roman villas, predicting color, texture, and artistic style based on historical samples. The result isn't fantasy, it's statistically plausible history, rebuilt by machine learning. But how does this actually work? At its heart, AI reconstruction combines data layers, spatial geometry, cultural context, and artistic inference. Let's take the Temple of Artemis at Ephesus. Only a handful of columns remain, but historians have textual records and small fragments of marble reliefs. By training an AI on similar Hellenistic structures, researchers can predict architectural symmetry and structural dimensions with remarkable accuracy. The algorithm doesn't just copy, it learns the language of ancient architecture, filling in missing grammar with digital logic. This approach has redefined archaeology from an art of fragments to a science of probabilities. It blends human intuition with machine precision, where a historian might spend decades debating how a statue once looked. AI can generate thousands of potential reconstructions in minutes, each rated by confidence levels derived from pattern recognition. Let's turn to Egypt. Deep in the sands near Saqqara, AI systems developed by the Smithsonian and IBM's Watson analyze hyperspectral images to detect chemical traces of buried structures. The AI doesn't just see it, interprets. BI, combining spectroscopy with pattern learning. It can estimate the density of stone beneath the surface, predicting whether a site hides a tomb or a temple. For archaeologists, this transforms the excavation process from guesswork into guided precision. But this renaissance isn't without ethical debate. What happens when AI starts filling in the blanks of history? Can a machine truly recreate the artistic spirit of an ancient sculptor? Scholars argue that while AI reconstructions may be visually stunning, they risk blurring the line between history and hypothesis. Is it history if no human ever saw it that way? Take the case of Babylon's Hanging Gardens. No definitive archaeological evidence has ever confirmed their location. Yet, using a AI-driven simulation based on ancient texts, hydrology models, and geographic data, researchers at the Max Planck Institute have recreated a functioning model of how such gardens might have existed. While the visuals inspire, all historians remain cautious, reminding us that every AI reconstruction is both a discovery and a dream. Still, the benefits are undeniable. AI is democratizing archaeology. Open-source platforms like Google Arts and Culture's Open Heritage project are using machine learning to allow anyone to virtually walk through ancient sites in photorealistic 3D. In 2025, UNESCO adopted AI-based modeling as part of its preservation guidelines for endangered heritage sites, ensuring digital twins exist before physical decay erases them forever. AI's role also extends into restoration. In Greece, neural networks trained on classical statues have helped conservators predict missing facial features and proportions. In Cambodia, the Angkor Wat restoration project uses robotic AI systems to analyze stoneware patterns and suggest reinforcement techniques. Machines don't just rebuild, they protect what's left. And then, there's the narrative layer. Generative AI is now being used to reconstruct not just images, but experiences. Imagine donning a VR headset and walking through a fully recreated city of Uruk, guided by an AI narrator that explains trade routes, rituals, and architecture in real time. This fusion of storytelling and data is changing how museums, educators, and filmmakers engage with ancient history. The implications go deeper. Archaeology has always been about understanding who we were, and, in doing so, who we are. When AI participates in that journey, it challenges our sense of authorship. Are we the interpreters of history, or are we now collaborating with algorithms to co-author the past? In the Western world, institutions like the British Museum, the Louvre, and the Getty Center are embracing AI-driven curation. AI algorithms analyze artifact collections to find hidden relationships, trade links between civilizations, stylistic evolutions, or material origins. The result? A new, data-informed view of history that transcends borders. Across the Atlantic, US researchers are pushing boundaries with archaeological robotics. Boston Dynamics prototypes equipped with AI vision now map ancient tunnels beneath Mayan ruins, places too dangerous for humans to explore. Every discovery expands the dataset, feeding back into models that can predict where the next lost wonder might be. Economically, AI archaeology has also opened a new frontier: heritage tourism in the digital age. Virtual reconstructions of lost sites generate billions in online engagement and educational tourism. UNESCO estimates that digital heritage experiences could contribute up to $12 billion annually by 2030 through virtual exhibits and immersive media. Culturally, we are seeing a rebirth of appreciation for history. Younger generations, raised on technology, are engaging with ancient civilizations not through textbooks, but through AI-powered apps that let them visualize history dynamically. AI becomes a bridge between the analog past and the digital future. Still, amid the wonder, a quiet question lingers. When the ruins of tomorrow are discovered, centuries from now, will AI itself be one of humanity's lost wonders? The code, the machines, the datasets, will they too become relics of our civilization's own story? In the end, the partnership between AI and archaeology reflects something profoundly human. The desire to remember technology at its best doesn't erase mystery, it illuminates it. By using intelligence, both artificial and human, we ensure that the beauty of ancient ingenuity continues to inspire future generations. This has been AI Pulse Daily, your front row seat to the frontiers of intelligence and imagination. If this journey through the past and future inspired you, make sure to like, share, and subscribe. Join us again as we decode the next revolution, shaping our world. Until then, keep your pulse tuned to the rhythm of